So, hello everyone. It is a pleasure to be here today in Seattle. Today I'm going to talk about the data that players generate, and what we can do with them to predict their behavior through machine learning models. So, just wanted to introduce myself. My name is África Periañez. My background is theoretical physics. I have a PhD in mathematics in assembly learning. And since 2005, 2006, I've been working in data science in different fields. I started my career at CERN in the Particle Physics Accelerator in Geneva, and since then, as I said, I've been working for academia and industry, predicting different kind of behaviors from Coca-Cola, energy, also working in research in recurrent neural networks, etc. But it was in 2015 when I was in Japan working with satellite data in an operational center when I discovered game data. So we're a game studio, Silicon Studio, and a spin-off of Silicon Graphics, that were asking for data scientists to understand and predict player behavior. So then I talked to the CEO, and I proposed let's analyze those data, but what about creating a platform able to provide this kind of intelligence and knowledge to other game studios? So this is how everything started. It was founded in 2015, and we joined Keywords. We were acquired by Keywords Studios last summer. What is our main purpose is push the frontiers of general behavioral machine learning. So this means that we use machine learning models that are able to adapt to any data distribution, to any player, to any kind of game. So our models must generalize well, no bias, in a way that we are able to predict players when they're going to quit, for instance, for very casual games, for MMO or RPG. The behavior is completely different, as you can imagine. And, we also want to, we go in one direction, what we think that is the right direction, that is happening in almost every field, every data field, every industry, is towards personalized games. What we are doing with our models, first, we are able to open those databases, normally very big, that almost most of the game studios are not able to extract that information, because basically the data are huge. So, and we focus on predict behavior and to provide actions. So, we predict behavior of players, but we want to do something with them. So we want that game studios are able to retain, to engage, etc. So, and also not only predict, it's very, very important for us to understand what is going on, to understand your players, what they like, what they don't. And also not in cohorts or groups. We want to predict in individual level. Why? Because the quality of the data is so big, is so good, that allow us to do this. How we are doing this? First of all, we have one of the best teams in the world in terms of data scientists, machine learning engineers, and data engineers. These three blocks are extremely important for us. We don't do classical data science, reporting, and do presentations. We do all on production. So data scientists do very sophisticated models, and machine learning engineers try to how we can put this in a scalable way. And data engineers are able to do everything distributed, from the data upload, from the feature engineering, from the results, etc. What are our fundamentals? So we have a very strong relationship with academia. We also publish our papers, and we also have entrepreneur mind, so we try to execute very fast. We put in production actual scientific research. So we are not developing our own algorithms from scratch. We try to focus on different fields, different scientific fields, or even industry fields, that they are using models robust for years, sometimes decades, and this is what we put in production. We adapt to solve the business problems or the business challenges that this industry have. And also interdisciplinarity. Because of the nature of our way of working, we have employees, from all kinds of backgrounds, not only diversity in this way. I mean, also background. So we have theoretical physicists, mathematicians, computer scientists, engineers, etc. This is one example of the kind of outputs that we try to focus. We focus on long-term predictions. If we predict that a player is going to leave tomorrow, you almost don't have chances to take any action. So we normally are able to predict mainly with very loyal games, with 2 months, even 6 months ahead, when a player is going to quit, which date, until what level this is going to happen, or in what stage is more likely that every single player is going to leave the game, how many hours it's going to take for every player until they get bored, and how much money they're going to spend into the game. We have a very sophisticated lifetime value prediction. We also have incorporated in our platform and also connected into the game an item recommendation system. Why we have this? We do this because, okay, we know a player is going to quit in a couple of months. How we can make it to retain this person, to retain this player? Then we know every single player, what are the items that are more likely to buy, and what are the ones that they want to purchase the most. So with our model, we know day by day, player by player, what are the interests in terms of virtual items or actual items for every single player. So then you can decide automatically and can be full automated if you want to give a reward to engage them again, or you want to give an 80% discount or a 10% discount to increase their in-app purchases and also to engage them again into the game. How are we doing this? This is just a schema of our item recommendation system. One of the challenges that we have is that sometimes the dimension of the items is huge. The dimension of how many items are in some games is too big. So then we apply an unsupervised learning model to reduce the dimension of it, and we do groups. So we apply machine learning models to understand which are the players that prefer different kind of group of items. Then we use a collaborative filtering to, again, be able to move from the group of predictions of items to the actual item that every single player is willing to get next. Our results are really, really good with this item recommendation system. We also focus not only in applying data, behavioral data of the players, we also include in our system external information. We include weather information, we do events information, Christmas, Chinese New Year, a sports event, even, if it's the final of the Super Bowl or the final of the Champions League. These kind of models are, of course, localized because it's not the same effect in every part of the world. So what we do with these is to be able to recommend what is the best moment to apply a marketing or promotion campaign and try to maximize this effect. Sometimes doing a campaign, right before Christmas is a great idea. Sometimes it's the opposite. So all models analyze the past information and recommend you what is the best timing for doing those events. This is for marketing and promotion events and also from game events. It is a good idea to put my best game event together with this promotion and precisely, for games like FIFA in the final of the Champions League, maybe yes, maybe not. So these kind of models are able to recognize those correlations. And as I mentioned before, we focus on personalization. We understand that predictions cannot be in another way as individual only. And this give us space and move forward to personalization of games, to give rewards, to give recommendation of actions for players, and even be able to adapt the game as long as the player is evolving into the game. So we focus not only in how players play, like behavioral personalization, how do you play, also external information, like how do you play under certain events? How do you play when you go to work, when you come back, or when you're on vacation? Be able to recognize all those effects and try to adapt the game for your needs. for instance, as well, personalization in a way to which is the best clan in the class of clans that is going to maximize the fun depending on the time, and with whom you should compete against in Mario Kart. These are examples of the personalization that this is already done in some areas, in some industries, but still is missing in video games. And it's very surprising for me. Why we should do this? Why we should rely on data? Why we should move forward and be much more data-driven in video game industry? Well, basically, and already Amos Tversky and Daniel Kahneman, that won the Nobel Prize in 2002, say it. Man is a deterministic device thrown into a probabilistic universe. What does it mean? It means that if we have a model, a good model, to predict behavior, it is much better that we use it because we are very bad doing predictions. So here I remark these sentences are from Amos Tversky, so I like them. People predict very little and explain everything. People often work hard to take information they already have and try to avoid always new knowledge. And I think everyone sees this on a daily basis. So, and everything that has already happened must have been inevitable. Well, I think this is obviously wrong. This is an example, this is a scenario of how much money you can make if this is a very conservative scenario, okay? This is a big game, a big title, mobile game. And this is just an example of how you can make, using, I insist, in a conservative way, data science to improve and to improve retention, to improve the development of the game. So for instance, if we manage to increase just for 1 month your VIP players in a 10% of them for 1 month, it means an increase of $1.3 million. So if we increase just the number of PU, because we have a feature that tells you who are the non-paying users, who are potential paying users, and try to provoke this flip, this will mean $4 million a month in sales increase. And if you improve those levels, because we also spot which are the parts of the game that are more likely, that are making your players leave, if you improve those critical, maybe normally we spot 10, those levels, it means 8 million a year. And this figure, the 8 million a year, because of improving the development, for casual games and for more indie games is much bigger, because normally they don't spend so much time in the development of the game. How are we doing this? So, as I said, we have created a platform and we focus on operational player behavioral prediction. So every day the data are feeding, every day we update the models, and every day everything is refreshed. 24 hours, 7 days a week. And we also focus a lot in visualization of the results because we want that this information go across the whole company, from executives, marketing, game planners, for, of course, developers, in order that they support the decision-making process with data. Which model do we use? We use everything that works. We are not only doing deep learning, we do deep learning, but also ensemble learning and other statistical learning techniques that are robust and work well. And also we scale with big data. This is very important because the data are massive. We are working with games that are huge, with millions and millions of monthly active users and historical data sets from 16 years. So ensemble learning is just, I don't want to go very deep on this, but rather than running only one machine learning model, we run a cloud of them. And rather than taking one result, we are taking a statistic of the results that we obtain. So normally, it depends on the ensemble learning that we use, but normally gives very robust results. And it are able to be parallelized. This is extremely important with the amount of data that we have. We use as well deep learning, as you know, rather than using only one layer of classical artificial neural network approach. We use several layers to make the non-linearity much bigger. On the other hand, we are not able to explain what is behind, something that we can do with ensemble learning. But in our cases, when we choose it, it's because the accuracy is very high. For our lifetime value model, we use convolutional neural networks, for instance. One of the advantages that why we use this is because we can input directly raw data into our models, and at the end, it was working much better than other models. So this is what we have in production. So for instance, we want to predict how much money they are going to spend every single player since today until they leave the game. So in that way, we can give proper rewards. We can try to engage them again, the ones who are going to be finished, to finish in terms of lifetime value, etc. What is the challenge that we have? I mean, this is today, and here we have the date. I mean, and here we have all the different players. So we have some players that have, long historical information, and others just started the game. And for all of them, we need to predict how much money they're going to spend with the maximum accuracy. And also, we don't know the churn day. So at the end, what we did is connect our churn prediction model together with the CNN, and it turned out very robust result to be able to be in production. As I said before, we are connected with academia, and we publish our own papers. Why we are doing this? This is just a marketing campaign. It's how we do marketing in Yokozuna Data. So we try to show that we are doing serious work, and we really put research into production. So you can check, this is in our website, if you want to have a look to the models that are in production in our platform. And this is just an example that we participated in 2017 in the first competition of video games by Computational Intelligence and Game held in New York. There were 2 tracks. The data were from NCSoft, and we had to predict which players will leave the game. I mean, the binary prediction, who is going to leave in a certain period of time, and which day this is going to happen. And this was a very useful it was very useful in terms of benchmark our models with other teams and with other companies and academia researchers. So we won in the 2 tracks with quite, mainly in the track 2, that is the most difficult with a significant difference. Normally in data science competition there is no such a gap. So it was a good way to measure the quality of our models. And as I said, I want to put one slide more about the big data architecture and infrastructure. So as I said, we need to be fully distributed from the data upload, for the feature engineering, for the data preparation, and for the execution of the machine learning models. So this is a schema of the architecture that we have. So we have Spark cluster. We use Cassandra as a main database. Then we have the computer servers that for small computation we use R or even Python, PySpark. And the platform is managed in Java, also PyTorch. When the model is complex, we translate directly in Java, for instance, to make it fully distributed. And then we have the part of the visualization of the results that I would like to do a very quick demo. Just in the 1.5 minutes that remains. Okay, this is the shape of our platform that again connects to the backend of to the servers of the game. So the action that you can take are also reflected into the game. So this is just the dashboard. Which are the levels that makes your player quit the most? You can go through this and understand, what is going on in your game. This is the sequence of game events that maximize sales in the next 2 months, or that maximize play time. So what is it? How many players are going to quit immediately, in 10 days, in 1 month, etc. So going very quickly, I can show you, for instance, the life expectancy model. So here we have players who are going to quit in 9 days, as I said before, in 1 month, 3 months, etc. And we have player by player. We show this in order that you really feel, that we are doing individual predictions. So, for instance, this player is going to quit in 630 days. This is an RPG, I mean, Japanese, very, very loyal game. And until the last level is going to achieve is 207. So this is just an example. Here we have, I mean, the most loyal ones, the ones who have a shorter life expectancy. And here is a summary. For instance, the guys who are going to live between 30 and 90 days. Everyone is in the different stage of the game. Some of them, they work for 2 years, others for, I don't know, 1 month, but they're going to quit relatively soon. So then you can take directly, for instance, a push notification if it's a mobile game, or you can directly send a reward. So, for instance, like a discount item, okay? So we can say 10% or you can say 90%. What is the item that they are going to receive? The item they're going to receive is based on the item recommender I mentioned before. Again, for player by player, we know what is the most likely item they would like to purchase next. So automatically, this is the reward or the discount, I mean, the reward that they will receive. And then everything can be automated. So, and you can follow up, and you can do A/B testing automatically as well to evaluate. I mean, it's better that I put 10%, it's better that I give a full reward, or this 50% is enough. So this is how you can follow up every action that you take. My time is over. And well, we can also do simulation of game events and marketing campaigns, so you can just play around. Okay, what about if I do this super game event and I run my marketing campaigns at the same time, whatever, and you run it, and you observe how the future sales are going to behave and how it's going to affect in terms of the play time. So, thank you very much.
So yeah, I mean, obviously we haven't got a huge amount of time, but you can see there's a huge amount of potential when we use this kind of technology. One question I have is, how much time or amount of data is required before you can start getting some level of accuracy? Because I suspect that you need to have quite a lot of data to get the level of accuracy you're kind of talking about. Is that fair?
Yeah, it's very long. We have a first phase of research that maybe takes 3-4 months. Then we pass to the next step, that is production. And then sometimes, okay, look guys, I mean, data scientists, you're great, but this is impossible to put in production, okay? And the engineers, the machine learning engineers try to get something similar. They come back to the data scientists and back again. And finally, we got a version that we are all happy, more or less. There is always a commitment between the three teams. And then we start doing all the scalable, the feature engineering, the model, etc.
But presumably design still plays an incredibly important part of that, because presumably you need to know that you're not just making something which is an item that's pushed to somebody, you want them to actually be engaged in something. Is that
Yeah, exactly.